Hello, it's Prof and welcome to C++ Digest video tutorials. In this tutorials, you will learn some basic terminologies used in programming. If you want to know more about the evolution of computer programming languages, I suggest you can get online, Google, and you have a lot of materials to read on there. But in this tutorial, I want to introduce to you some of the terminologies that you may come across. Now, we have something called assembler. Previously, there was a programming language called assembly language, and this was one of the old ways of doing programming. And to do programming in assembly language, you needed program called an assembler, and what the assembler does is to translate a program written in assembly language into an equivalent machine language. The machine language here is, as you saw in the previous tutorials, the zeros and ones that the computer understands. Then we came to high level languages. Now these ones, because of the tedious ways that assembly language gave, you have to remember certain things and you have to be coding closer to machine language, which was not that comfortable. So they developed the high level languages. And when we talk of a high level language, these are programming languages that are closer to natural languages like English, German, and the French. So C, Fortran, C++, Java, Ruby, they are all examples of high level language. And I know you will get what it really means to say a programming language is a high level language. Now, to program in a high level language, because that language is very close to our natural language, there is something you need a program that will intermediate your high level language and the machine language, because the machine language is what the computer needs and is what should be supplied to the computer. So there is a program called a compiler. What a compiler does is that it translates a program written in any high level language into an equivalent program in the machine language. So we have examples of compilers like the GNU compiler, the Cygwin, and all other compilers. Then you also hear of a text editor. Actually, a text editor is any program like Notepad that can be used to write a program. The notepad I'm talking about is not your notepad for recording notes at church or at class, but then I'm talking about a computer notepad which you can use to write any programming language. And take note that notepad is kind of universal text editor, because you can use the notepad to do a lot of programming languages, including web designs like HTML5 and CSS. So the text editor or the notepad is considered as a universal text editor. Then we also have source code or a source program. Now, a program that is written in a high level language is called a source code. Is that right? What you type in that text editor, if the programming language in which you are developing is a high level language, then what you've typed is called a source code. In case you don't get it, don't worry. When we get into the IDE, you will know what a source code really is. Then we have what we call a preprocessor. A preprocessor is a program that produces its input data to produce output that is used as input to another program. So it's a kind of a preprocessor is a program itself. Is that right? But that program is to be used in another program. So before the main program we are developing gets compiled, the preprocessor has to be compiled so that its output will be used in the main program that we are using. You certainly come across preprocessor directives when we get inside the IDE. Then we also have the object program. Object program is simply the machine language version of a high level language program. Remember, we said that a high level language is closer to our natural languages like English, French, and German. So when you write a program in a high level language like C++, Java, and you compile it into a machine language, you produce what we call an object language. And this object language is the machine language version of that particular high level language program that you wrote. Then we have software development kit. Software development kit, which is commonly called the SDK, and it's actually a program used for writing a high level language program. It contains many other programs that are useful in creating high level language program. So example of this software development kit, we have the Visual C++ and the Visual Studio.NET. We have the C++ Builder, and we have Code Warrior. All these are software development kit that helps you develop high level language programs. Library. When we talk of a library, is a collection of pre-written programs or codes. For example, when we get into the IDE, you know that the program that you'll be using to output whatever information you want to output to the screen is something that is pre-written, is pre-built, is that right? And all those things are already in the library. If those things weren't there, that means that whenever you are writing any program, you will have to take care or cater for writing to the screens or even accepting input from the keyboard. But these things have been pre-written so that you just call them and use them in your program. You don't write new ones unless if you want to do that. But in programming, there is something called do not reinvent the wheel. If there is something that has already been done, you don't waste time to redo that. Just use it and make life easier. Now there is something called a linker. And a linker is actually a program that combines the object program. And remember, object program is the output of the compiler, the conversion of a high level language program into a machine language equivalent. So the compiler links this object program with other programs in the library, like I said. For example, the preprocessors output and other pre-written libraries codes that you will use. The linker's job is to put all this together and create what we call the executable code. And the executable code is actually what you double click to run. Is that right? That is what you double click to run, and it's also what we call the binary code. It's what you double click to run. Then we have a loader. When the executable code is created, it is stored on your hard drive. And if you remember, I said in my first tutorials on computer review that before anything gets executed in the computer, that thing has to be loaded into main memory. So the loader is the program that loads your executable program into the main memory so that it can be executed. So whenever you double click any executable code, the loader plays its function by loading that code from the hard drive into memory so that it can be executed. Then we also have the interpreter. Actually, you will not come across interpreter when you are dealing with C++, but there is a need to know what it is. Programs like Python, MATLAB, they are interpreted, and interpreting is quite different from compiling. Interpreter kind of directly do what you have written in your code, but the compiling or the compiler converts whatever you've written in your source code to a machine language before it can be executed. But with the interpreter, once you run the code, it kind of starts working without being compiled. Whatever logic you've written down start executing, and it doesn't compile. So Python, MATLAB are such kind of programs that are being interpreted. Once you click the run, the actions that you've written down or your source code begins to execute, and when it comes across any error, it stops at that point. Unlike the compiler that will have to run through your computer, and if there is any error, that error will be thrown at runtime. So take note of that. Interpreters execute the code directly without compiling them. An example of programs that are interpreted include the Python and the MATLAB. Now let's look at how a C++ program is being processed. If I have a C++ program, if I want to write any C++ program, the first thing I need to do is I need an editor. And the editor, it can be any text editor such as Notepad. Is that right? So after I've written my program or whatever code I want to write in my text editor, the next step is the preprocessor. Now what we have here, #include IOStream, is called a preprocessor directive. It directs the compiler to where or what particular preprocessor that we want. So the preprocessor comes into place, and then after preprocessing, the compiling also happens. The compiler converts your source code to a machine language version. Then the linker will take the output of the compiler, join it to any library or previous function that you've used, and produce an executable file. The executable file is loaded by the loader into your memory, after which execution of that program occurs. Now as a developer, all you have to be concerned with is this aspect. Is that right? When you are actually writing your code, you should understand the syntax for doing that particular program. So you should be concerned about learning the syntax for building a C++ programs. The rest are not something that you should be worried or concerned about. Then we also have something called integrated development environment, or the interactive development environment. It's a software application that provides comprehensive facilities to computer programmers for software development. An IDE normally consists of a source code editor, a build automation tool, and debugger. You will come across this and I will explain them in due time, so don't get bothered if you don't get those things right now. Then several modern IDEs like the NetBeans contains IntelliSense. IntelliSense is just it's a program that kind of highlight errors and give you suggestions for you to do when you are programming. So on screen here, this is the dev C++ IDE, and that is what we shall be using for this C++ programming course. So if you don't have it, then watch my next tutorial. I'll show you how to get it and install it. Alright, so to write a C++ program, you need a text editor, a C++ compiler like the GNU compiler, and a PC. Definitely that one is a must. Or you need a PC and an integrated development environment like the dev C++ IDE that we'll be using. So with that, you have your text editor, your compiler, your debugger, and any other tool that will be necessary for C++ programming integrated. So all you have to do is to install a copy of any IDE. Then finally, and the most important thing, is your love and passion to learn C++. Because trust me, sometimes you can sit on an error for quite a very long time. It may take you days, and it is your love and passion to learn the programming that will keep you going. So thank you for watching this tutorial, and don't forget to send your comments, suggestions and questions on my WhatsApp group or Facebook page, C++ Digest. Thank you. See you in the next tutorial.